All right, so what we're going to take a look at today is the full rigging process, start to finish, of a basic prop. And the prop that we're going to be looking at is this minecart here. So the first thing that you want to do when you're given a scene is to basically review what it is you've been given. This is a model I did not make. It was given to me by a colleague, and I don't really know what's going on here. So the first thing I might notice is that my outliner here doesn't really have any names. It's kind of a mess. So I'll probably want to come through and name these as a rigger, so that way I know what they are. And I want to check other things like the pivots, where the pivot's at on this thing, and basically how does it intend to move. This is going to take a little bit of experimentation, but all things I can figure out. So you want to come in here and just kind of check these things. We can see these are the wheels here. And one of the things I'm going to immediately notice is that these wheels are combined. They're not separate. So what that means is I'm going to either have to drive these through skinning, or I'm going to have to separate these if I want to do something different, like a constraint system directly on the geo. Now, I do want to talk a bit about skin versus doing, direct constraints on geometry. Generally, this is what we always want to do. We want to bind the skin here. I don't know if I'm going to do that on this one because, unless you're going to a video game specifically, you can kind of get away without doing this. But the other thing I kind of want to call out as well is we can set up a system with groups that allow us to do this as well, using references to kind of swap in geometry if we constrain things to the groups. But to keep this as simple as possible, what we might want to do is just separate these out. Before I dive deeper into that, though, let's just check everything else. We have a bucket, we have kind of a shaft here, main body, and then we have these wheel wells here, these wheels. All right. So we have to determine if this is what we want, or if we want to shuffle things out and separate them and make it easier to work with on our part. And like I mentioned, once again, ideally, we'd probably combine everything here, have a set joint system, bind that to that joint system, but we can explore that later once we get more comfortable with skinning. To begin with, let's go ahead and separate these out. I'm going to select these wheels here and just do a mesh separate. That's going to break them into separate chunks, so now I can select each of them. And I'll do the same thing here with the wheel wells. I'll do a mesh separate. What I'll then do is kind of recombine these into how they should go. So for example, these front wheels here, they're probably going to always roll together. This looks like a single drive shaft, so whenever one side rotates, the other does. It's not complex like a car where they could potentially be separate. Actually, I think on a car that bind too. We can take all these, just kind of shift select them together and do a mesh combine, and then do the same one with these back here. Do a quick mesh combine. Now, another thing you want to do is look at the outliner just to make sure everything's zeroed out. And it looks like it is. Now that we combine those, it would be a good practice to just highlight everything on the rig, do an edit, delete all by type history to kind of clear this out, get rid of those extra groups, and to start naming these. So this, for example, would be the front underscore wheels. This one here would be the back underscore wheels. This here would be the main body. I don't know what we'd call that on the minecart. I'll just call it cart. And then here we have the tracks. So we can go ahead and call that our tracks. And then this is our bucket. And then I think the term for this is an arm. And the only reason I can think of that is because my children watched Blippi, and now I know everything about excavators. So yay. All right, so that kind of gets us set up here. We're kind of good. We have things kind of chunked out the way we want. We got our wheels, our bucket, our arm. I think this will work. There are other things though, like for example, do the arm and the bucket need to be separate, right? Is there ever an instance where this is going to turn here, but this isn't going to turn here? And the answer to that's probably no. So we could simplify that even further. We could go ahead and combine these, and this is going to make our life a lot easier because all of a sudden, if we go ahead and delete history on this, and I'll just name this the bucket, you'll see really all we're dealing with is a cart, front wheels, back wheels, and a bucket. So we can, pretty easily figure this out. So once we have this in place, the next thing I'm going to do is start to kind of think about my file structure. How are we going to structure this? And remember, we want to work in a way that is going to facilitate a pipeline workflow. If I take a look at this model, does it look finished? And the answer could be yes. This is a relatively complete model, but does it have textures? And pretty quickly, you can tell if you turn on the textures or look at the UVs, it does not, which means this is unfinished. What that means is I want to keep in mind how we're going to work in a pipeline kind of format. So what we're going to want to do is basically work with a reference here where we have our geometry in one file that's basically still being worked on, and then we're going to reference this in to a rig file where we're actually going to build our rig. In order to facilitate that, let's go ahead and set up a project folder for this asset. Ideally, in a production workflow, we'd always be in a project folder, but even when you're working in disconnected workflows, it's good to have these project folders. For example, when I work in video games, a lot of the times we have kind of like a central version control folder. And that usually is going to be the video game, but we'll also have kind of a subfolder off to the side for art assets. And it's very common for us to have one project folder per rig, which is interesting. This is kind of unique to games because in film, you're going to be doing this all in the same project folder. But it's something to be mindful of if you're doing your own workflows for your own rigs. It makes it much more versatile, easy to use, and you can always merge structures later if you need to. So let's get that set. I'm going to come up here to File and New Project. We'll just come to our project window. Click on New here to create a new one, and then set our location to be somewhere we can find it. This is a part of a larger class that I'm teaching, so I'm going to place it within that folder, so that way I can come in here and find it a lot easier. And we'll go ahead and set our folder here. I'll make this my Minecart rig Maya folder, and just hit accept. Once we do that, this will be created, and what we can do is we can do a file, save scene as, and we can go ahead and start creating our file structure here. What I suggest doing is having some sort of subfolder structure here. Like I mentioned, if you're looking at this in a larger production, what I would suggest doing is creating a new folder here, calling the master folder or something like props. Double click into props here. You can have a new folder here called geometry, or you might call it models. That way we know these are the modeling files, and then we can just go ahead and say this is our Minecart start, and we're good to go. So once we have this in place, we need to start thinking about the function of this and how it's going to move and how we're going to kind of structure it, right? Right now we're in our scene file though, and remember we don't want to be in our scene file because if there's any updates to this, we basically want that to propagate into our rig if possible. So let's go ahead and clear out this file. We'll just go to a File, New to create a blank scene, and then we'll come back up here to File and Reference Editor to reference our file in. In the reference editor, we can hit the plus icon. This will allow us to bring a reference in. When doing so, it's a good idea to kind of review the settings on the side here. Depending on what you have here, you may need to make some changes. One of the things I generally like to do is merge into selected namespaces that match, meaning that if we're just bringing in one prop into the scene, we're not bringing in multiple of this prop. This will retain its original naming without a prefix or suffix. So this is what I usually like to have. If you don't have that, it's not a big deal. It's just going to make it a little bit more wordy in terms of the geometry. So we can come into the props here, we can come into the models, and we can go ahead and grab our Minecart start and click reference. You'll know it's a reference because over here we'll have this blue diamond. But this is a little bit of a mess, and we have to ask ourselves, do we want to organize it here within this folder, or do we want to organize it within the modeling folder? And that's ultimately going to depend on the pipeline. One of the things that can be nice about organizing it in the modeling folder is it makes it so that the modeler can update it within there, and then it will update correctly within our folder. It does take team coordination to achieve that, so I do want to call that out here, but sometimes it's better to organize it in the source. So let's take a look at that real quick. Before we go back to the source file, let's save this. I'm going to do a File, Save Scene As. We're going to hit the up arrow here, and we're going to create a new section under props here called Rigs. And in here, I'm going to create basically a WP folder for work in progress, and we'll just go ahead and make this our Minecart start rig. So now with referencing, what's really cool is I can go ahead and open, we can come back to our modeling file here, and we can make the necessary changes that we need. For example, I could take all of these elements, I could hit Control-G on them, and I could make this our Minecart _geo. That will have all the geometry nested. And if I go ahead and save this now, and we go ahead and come back into our other file here, which is going to be our Minecart start rig, you'll see that is in a folder. So that way we can have that set. And I called it a folder. What I mean is a group. And we're good to go. Now, we are basically ready to rig, but before we do, we want to think about this a little bit, and we want to think about our MVP, our minimum viable product that we need to create for this. So basically, at minimum, what does this need to do? And this is something you should always do with props because it's just kind of good to put in some pre-thought. So there's some obvious ones we have here, like the buckets. This bucket needs to rotate. And while we're here, we can kind of think of where we might want to place the joint. I could very easily place the joint here because it needs to rotate. Now, this is where things get kind of tricky. This runs all the way through. And what's kind of neat is we can just have a singular joint on the end to control all of these. We could also place the joint at the middle if we felt it had any sort of purpose. So we can kind of decide how we're going to set that up. But for me, we're going to have this joint here. And what that's going to allow us to do is basically rotate the bucket. That's going to be one of the most important things that we need to have happen here. Now, the next thing is obviously going to be the wheel rotation. The wheels need to rotate. So we're going to need to have basically a central joint here and a central joint here that make that wheel work. At this point, this is probably the MVP. Wheels roll, bucket turns. But this is where we might want to think a little bit further. So minimum viable product to get this animated, we really just need a bucket and we need wheels. But how do we move it forward? We need an ability to move it forward and backwards. We're also going to need a main control, right? So we can nest this underneath these. And this is why it's good to think about this. Now, what's interesting is if you guys haven't built rigs before, all we're really moving is the joints. So the main control doesn't really need its own joint. It can just move the other three joints and that will move the entire system, generally speaking. But it depends. You know, we need something to constrain everything else to. So in that particular instance, we might add a central joint here that basically represents the body, right? So 3 joints in total. Now, after that, we can kind of think of things that are nice to have. So an example with this is if we're animating, what if this thing comes to a screeching halt in a cartoony way? Well, it could just stop like this, or it could come up on its front wheel like this, in which case we would need to add a front pivot. And if we have a front pivot, it might make sense to create a back pivot where it could go backwards. So we might want a back pivot. And if we have a front pivot and a back pivot, it might be nice when it's going around a curve if it could tilt up on a single side wheel. And I said a single wheel because we might want to make it so it could go on just this wheel or just the back wheel. So we might want things like wheel pivots. And these are excellent examples of things that don't necessarily need to be there to make this function, because could an animator make this happen with this up here? The answer is yes, but these would make the animator's life a bit easier. So I think looking at kind of the bare minimum in terms of the MVP and the nice to have, these are really what we're going to be aiming for. This may change, but it's good to kind of create a head check list. So as you're heading into a rig, you can really kind of understand what it is this thing needs to do, how it needs to function, and what systems we need to build. Once we have that in place, we can start actually building our systems. Now, in this particular instance, what I'm going to concern myself with is joint placement. So we're going to come up here to our rigging menu. We're going to come up here to skeleton, and we're going to create joints. And I'll go ahead and start by placing a joint here. This joint's really large because this wasn't modeled to scale, which could be a problem, but for now we'll leave it be. You can always adjust the radius size over here, so I'll set this to 0.1. And one of the things that I like to do is generally turn on my geometry wireframe so I can actually see what I'm doing. I'll enable it here. That way I can snap these to specific locations. So I'll go ahead and start with the things I know. Let me go ahead and click off to another tool here. Set this to 0.1. And what I know is I want the wheels here. So I'm going to hold down V to snap and then X to snap to grid. I can't see that anymore. So remember, we can come up here to shading and X-ray joints. That way we can see inside of here. I can then hit Control D and X again to get it to the central axes. That'll be for the main cart. And then I'll hit Control D again here and hold V to snap to vertex to get to the wheel well. And this is a little bit tricky, but you want to make sure that's aligned. If you're not as confident with snapping as I am, you can come to something like the side view here. You can turn on shading and X-ray joints, and you can see those aligning nicely, perfectly with that central vertex. And we want to make sure it's aligning with that central vertex if we have it as a reference, so we can make sure it's revolving perfectly around that point. I'm not too worried about if this is an even distance from either of those, because this just represents the cart. While we're at it, we can also label these. So this here, for example, would be my front wheel underscore joint. This one here, I would call my root joint. The root joint is usually what we call the top joint of the system that moves the entire chain. And then this one back here would be my back wheel underscore joint. Now, I still need my bucket joint, and I have to decide how I want to represent that. Do I want to put it at the front? Do I want to put it in the middle? And like I mentioned, it doesn't really matter too much here where I put it. If I put it in the middle, if we had some sort of a contents being rigged in here, that could be problematic. So the best system might be to just duplicate this, hit Control-D on a joint, and just V and snap it to the front there. There's really nothing wrong with that if all it's going to do is tilt the bucket. And we could go ahead and just rename this bucket joint, and we're good to go. Now, we need to think about how these are going to kind of pair together, and fortunately for us, it's a very easy system, because that root joint is the central joint, and all of these connect back to it. So these aren't going to branch into anything crazy like we would have for an arm. They're really just coming back to where they came from. So we'll go ahead and take these as children, shift-select that root joint, and hit P to bring them back to this location. Now, the next question you have to ask yourself is, what about orientation? Orientation is where we look at that local rotation axes of these particular joints and decide, hey, do we need to change these? And this is one of those interesting rare exceptions where we really just don't need to. In this particular instance, world is just fine. The reason why is this is just rotating here as an object, this is just rotating here as an object, and then this is just controlling this entire thing in global space. So you don't always need to orient your joints. There might be some reason you want to, if there's a preferential axis you are operating on, but in this particular instance, we can actually consider these good to go, and we're ready to start building our rig. Now, in terms of that, it's good to save our progress, so I'm going to do a save scene as, and I'll go ahead and just save this as rig 01, so that way we have a progress state saved. So the next thing we need to determine is basically how is this going to be controlled? Who's controlling what and why? Now, ideally, what we would do in this instance is we'd probably use skinning to get this set up. But like I mentioned, you don't always need to use skin. And a lot of the times I like to wait to skin until we actually have the final model. Because if this geometry is going to change, we're going to have to rebind the skin anyway, and it's going to create more of a hassle than not. So what we could do is we could set up some temporary systems for the time being using constraints. And we can just take the respective joint to the respective object and create a parent constraint. So I can go ahead and select this object here. I can go ahead and shift select this object here and just do a constraint parent. You might notice this jumped out of place. Why is that? Well, the reason why is in my parent setting here, I have this little checkbox unchecked, which is maintain offset. I'm going to want to make sure I turn that back on. If for whatever reason you guys have weird settings, just remember you can come here to edit reset settings. That'll take you back to the factory defaults and we can hit apply. Now there's something I want to check here. When I rotate this, does it rotate from this point? And this is one of the challenging things you do run into when you are dealing with geometry versus skinning, is generally speaking, geometry rotates from its pivot. So if it's rotating from its pivot, it would be rotating from up there potentially. But it actually looks like it's doing fine here with this particular joint controlling it. So I don't think I need to move the pivot of that object to make this work. Just make sure after you're done testing to make sure this functions, you set it back to 0. We can do the same thing with the wheels here. I can select this joint, shift select this wheel, and then do a constraint parent. And then just make sure that this is actually controlling the wheel, and we can check that from the front. And it looks like it is moving correctly with no wobble. We'll do the same back here, joint to wheel, constraint parent. And now all of our little joints are controlling their respective parts except for the root, right? So if I take the root here, the root is not necessarily going to work off of rotations. It's going to work off of translates and rotates potentially. And you'll see it needs to control the body. So we can just select that root, select the body here, and hit constraint parent. So at this stage, our geometry and our joints have been constrained. combined. We are now working with these. Now, I want to emphasize, though, notice that using constraints specifically allowed us to maintain separate hierarchies. So our geo is its own hierarchy, and our joints are its own hierarchy. This is a very important separation to mix. You never want to mix your geometry and joints. And the reason why is you want it to be flexible. Like I mentioned, this isn't the final geometry. If I want to update this geometry later, I need it to be separate. So just be mindful of that. We can go ahead and save now, and we can start building our actual controls. For this, we're just going to use a basic FK system. Now, remember, when we create controls, what we generally use is we use NURBS curves, and the reason why we use NURBS curves is they don't show up in renders, so it creates a really nice invisible control, so to speak. One of the things I might want to be able to do, though, is toggle the visibility of this crate here. So I could take the Minecart geo here, and I can come over to my display layer under my channel box and create a new one. And what that will allow me to do is just toggle the geometry on and off to make it a little bit easier to place my controls. So let's get started with that. We'll go ahead and create a NURBS primitive here. We'll go with a circle, and I will just duplicate this circle out for the various controls we're going to be creating. We're going to need to have a handful of controls in general. We're going to need a front wheel, a back wheel, a bucket, and then we're going to need something that represents this area here. Now, the thing we want to emphasize on this is going to be usability. And something I want to let you guys know is you can actually create custom NURBS curves. It's using code. I don't do that. Why don't I do that? Because it takes a lot of time and it's just not worth it for me. Now, what the challenge is in that is that sometimes we're going to have to make some compromises. So for example, these wheels, they're technically controlled by a single controller. So where would be the best place to put that? The most logical place would be outside on this wheel. But to represent that it's both controlling this wheel and that wheel, it might actually be nice to place it somewhere that's centered. So what I could do is I could start by experimenting with this. I'm just going to hit Control D to duplicate. After duplicating, I can go ahead and rotate this 90 degrees. And then I can turn back on the geometry here and determine what would work best. I could look at it from the front or side or back. And you can see all of these aren't really great options. A very important thing I do want to do, though, is keep its pivot exactly right here. Now, a nice middle ground in this particular instance would be to get it to be here, so we understand it controls the wheels, and then just move it off to the side. However, notice if I move in geometry mode, the pivot moves. What we can do to position our curves where we want them to be is we can right-click on the curve and switch into something like the curve point mode or the control vertex mode. If we want to move the curve but not the pivot, we can move its components. We can do so by right-clicking and coming into Control Vertex. This will allow us to access the vertex of the curve. We can then highlight these and move them. You might notice, though, we run into a bit of an issue, and that's that our selection order likes to pick the joints. So what I'll usually do is I'll go ahead and just bring back the geometry, select this in isolation by coming up here to Isolate Select. And this is going to be a very important tool to get used to. Isolate Select is right here. There is a hotkey for Isolate Select. I personally don't remember it because it's too many keys. This button's a lot easier to press. So just select the object you want to isolate, click that button, and now we can go into the control vertices. Now what's cool is with these selected, we can disable the isolate, and then we can just pull these outside where the wheel's at. So I can just pull these to the front here where the wheel is. And if you need to at this time, you could also scale this up or down. For example, I could place this smaller and on the outside so it's not super intrusive, or I can make it larger so it's very clear it controls this. I just have to be careful I don't interfere with the other wheel. Once I have this place where I like, I can go ahead and right-click and go back into object mode. And what you will see is that we have the curve visually out here, but physically right here. And that's going to be an important distinction to make. Before we can actually set this up as a control, though, you can see we're probably going to want to freeze these transforms. So we can do a modify freeze transforms. While we're here, we can go ahead and set this up for the back wheel as well. We can just disable our visibility. We can Control D this curve and just snap this guy to be back here. And we'll have our wheels there now. So that's really all we need to do to get the control set up. Just make sure you freeze transforms on these and get them in place. What I generally like to do, though, before I start hooking these up to actual controls, is I like to place all of the controls for the system. That way I know where they're at visually and nothing's going to interfere and overlap. So let's go ahead and get those other ones in. For example, for the main cart, I'll go ahead and duplicate this and just snap to vertex here. And to make this a bit bigger, but we can also shape this. So I can right click and go into control vertex. I can select these front vertices here. And once again, I might want to go into isolate to make my life a little bit easier. I'll scale these in to be flat. I'll scale these in to be flat and then do the same on the sides. So that way we get kind of the soft rounding square. And you can shape it however you guys like, whatever makes sense. I'll go ahead and bring back all my geometry here and turn off isolate. And we can go ahead and take a moment here to basically position this to look correct for the cart. So I'll make it a little bit more narrow, a little bit less wide. And I don't want it to interfere with my other controls, but we can see where that's at. Now, I could also decide if I wanted to align with the wheels there or if I wanted it to be a little bit higher up. I think for this will be fine. We can go ahead and freeze transforms on that, and then we can do the same for the bucket. Now, I want the bucket to probably have this square shape, so what I'll do is I'll turn off the geometry here. I'll go ahead and hit Control D, and I'll move this up. But remember, I potentially want the pivot to be coming from that front area. Before I do that, let me just make sure the size feels right. And the shape. One of the things I might want to do is make it a bucket shape. So I could go ahead and take the little edges here. I pull these up. And there we go. We got a little happy, scoopy bucket. All right. So I might adjust that a little bit, and I'll just bring it out front here. Let me go ahead and switch back to object mode to scale it out front. So we have our bucket control. Now we need to play around with that pivot. I'm going to start by freezing the transforms. And we can move the pivot of a control the same way we can an object. We can hit D to move our pivot, and then we can do V to snap. So you can see you can either move the curve or you can move the pivot. But you can see we now have unique shapes for each of these. We've identified this as our MVP, our minimum viable product that we're going to need to actually create this thing. So let's go ahead and name these. This will be my bucket underscore CTRL for control. This will be my cart control. Cart CTRL. Over here will be my back wheel control. And then this is going to be my front wheel control. With those all frozen and good to go, we can actually start adding some functionality to this. So let's go ahead and review the basic FK system that we need to get into place. When we create an FK system, remember what we do is we create an offset node above using a null, and we nest the control underneath. And you're probably thinking, hey, do we still need to do that because we didn't do orientation? And the answer is yes. It's really nice to have some sort of buffer between the control and the actual system it's in. There's a lot of things we can do with these offsets that could come into play later, and it's just a good support structure to have. So let's go ahead and start building that. To do that, I like to come up here to my Windows General Editor Hypergraph Hierarchy, because it just lets me visualize this a little bit better. And we'll go ahead and start to create that system. To begin with, make sure you have nothing selected and hit Control G. This will produce your null. The way you create a null is just having nothing. Pretty straightforward. From there, what we can do is we can select a joint, we can shift select a null, and to move that null to the location and orientation of that joint, we can just do a parent constraint here. But this time, we're going to uncheck maintain offset. And this is why mine was off originally, because the last time I was demoing this, this is what I did. We can then hit apply, and you'll notice that null jumped right to the location it needed to go. If we check the null's transforms now, we'll also notice it inherited a transform or rotation data. In this particular instance, we don't really need any of the data on it. We'll hit delete, and then we'll just go ahead and parent the respective curve to that. So the first thing I did was the front wheel. I'll select the front wheel curve, shift select the null we created for it, and hit P to parent. Notice when I nest the front wheel underneath, it does gain the transform data here that the null has. This is where we want to freeze transforms on the curve because we want our curves to be zeroed out for our animators, but we want to preserve the null so it understands the position this is at globally for better animation quality. So freeze transforms on that curve. And that's what we're going to repeat for each of these. So I'll hit Control G to create another null. select the back joint in this null, do a parent constraint without that maintain offset on, delete the null, and then parent the curve underneath the null. Then we'll freeze transform. What I encourage you to do at this point is really understand this rhythm. Null, constraint, delete constraint, parent curve, freeze. It's not rocket science. It is the same step every single time. Master it once, and you will master it forever. So don't let it confuse you. Just understand it is the exact same process. Control G with nothing selected for a null. Select the respective root joint. Shift select the null. Apply a parent constraint without maintain offset. Delete the null. Select the curve. Select the null and P to parent. Freeze the curve. And we'll do it one last time for up here. We're just going to Control G. Select the joint, shift select the null, apply our constraint, delete the constraint, select bucket control, parent it under the null, and freeze transform. So at this stage, we have it ready to be reconstructed into our hierarchy. Now, I didn't quite get to why this is important. You might have remembered that I set up these controls to actually, be in the right place. I didn't set them up to actually control what they need to control. So at this stage, once we have them under that null, we can go ahead and select the curve. We can then select the joint they're supposed to control and do a constraint. Now, if you've done the maintain offset correctly with your null, you don't need to turn it back on. You can just hit apply and nothing's going to jump out of place. It still can be a nice safety net to just kind of keep this on. So it's up to you guys. What I like to do at this stage is just kind of reset it. That way it's done. But you'll see now that I set up this curve to control that joint. We can use this as a control. All right. So we'll take this curve here. We'll go ahead and shift select its respective joint and do a constrain parent. And we can see that this now controls that joint. We can do the same thing here. We can take this curve, shift select that joint, do a constrain parent, and this is going to control that joint. There we go. Let me just check. Did that wobble? No, it didn't. I was just doing silly stuff. Okay. Then we'll do this last one here. We'll select this and we'll go ahead and do a constrain parent. Now, the next thing to remember is that even though this was originally a hierarchy, it's not anymore. These controls control their joints respectively, and you'll see the hierarchy's broken. So once you've gotten to this stage, what you need to do is you need to come back over here into this hot mess that you created, nulls and curves, and you need to rebuild the hierarchy. So what we're aiming to do here is we're aiming to assemble these controls the same way our joints were assembled, meaning that our front wheel needs to parent into our cart, and our back wheel needs to parent into our cart, and our bucket needs to parent into the cart, right? So the way we do this is we do null to curve, meaning that the null is the child of the curve. And this is one of the other reasons I really like this outliner. What I can do, for example, for the front wheel is we can find our front wheel's null. We can then shift select the curve, and notice I'm selecting the null in the hypergraph hierarchy, shift selecting the curve in the viewport. This way it just works, and then I can hit P to parent, and you'll see that will mess that underneath there. And now when I move this, you'll see that front wheel is going with it. We can do the same with the back wheel. We can take the null of the back wheel, shift select that front curve, and P to parent. And then we can take the null of the bucket, shift select that curve, and P to parent. And at this stage, what we have is a functional rig. We can move forward and backwards. We can rotate it if we need to. We have our bucket, which will swing. We have our wheels, which will spin. And we can even grab them together to spin them together. And you can see we have our functional rig. So at this stage, our MVP is basically done. This is an excellent point to do a save. And we can animate this. We really don't need to do anything else. However, we probably should do some other things. It didn't take us very long to get here. So what are some of the other things that we can explore? Those are going to be the idea of the pivots for the MVP, the front, back, and side pivots. Now, I want to emphasize these are nice to have. They're not required for functionality, but they'd be great to put in here. And we have to determine exactly how we're going to do that. The other thing to kind of be mindful of too is there's a lot of different ways we could set this up. We could set this up with a control. We could set this up with a attribute that we attach to something. So we have to think of kind of the best way to do it. But the other thing we have to think of is how. How do we do it? And this is probably the most important. This is where understanding how these hierarchy works can be very useful. So for example, whatever's at the top of the hierarchy controls everything else, right? So this is controlling the entire thing. And what we essentially need is something to control this. Now, it doesn't necessarily need to be something real. So what do I mean by that? If I take this null 3 here and I put it in a group, this group controls that null 3. So now this group's in charge. But what happens if I move this group? So for example, I could hit D to move it as a pivot, and I could just go ahead and snap it to a location like this. If I do that, all of a sudden we can rotate from the front like so, which is pretty cool. So all we need to do is something kind of like that, the ability to rotate from the front. What's challenging though is if I add another group on top, Control G, and I place it on the back, we could do the same thing here, and we can rotate this from the back, but the front and the back are in separate spots. So this is where it could be nice to get into a little bit more advanced rigging technique. Now I'm going to undo to get rid of those groups, and we can determine first off where they need to go and how they need to go. So one thing that I noticed is it actually needs to pivot from the wheels. That would be the most logical place for it to stop, for the wheels to pause, and then for it to tilt forward. The next is it can't tilt forward and back, otherwise it rocks. So those should probably be on the same control if possible. So this is where some of the problem solving of rigging comes in. I can start by hitting Control G on the null to create a group. I can then take this group here and I can snap its pivot to the joint of the wheel. This will allow this front group to pivot the front of the object from the wheel points. And we could go ahead and name this our front wheel pivot group. So front wheel pivot group. What I can then do is I can group this again, and I could go ahead and turn this off, and we could set this to have a back pivot wheel group. So I'm going to make this our back pivot wheel group. And as a reference, if I wanted to do this again, I could hit Control G to group this, and then I could snap this group to something like the front wheel side. And we can find exactly where we want this to go, but this could be something like a side wheel pivot. All right, and I can do that for the other side to basically make it so it can toggle. And I can determine if I want to do that. Do I want to do front and back? I guess we could. This would be my left pivot. You want to make sure it's pivoting from the right spot, though. You know, how do you actually want this to go? Do you want it to pivot from the outside or inside? You know, what would make the most sense from the point of contact? And I think on this particular object, the most logical point of contact would probably be the inner hub of the wheel here on the vertice. So I could D and snap to vertex here. So that way we have this set up. And you can see how that would set up our side pivot. So this will be our L, our left side pivot. And then we could go ahead and hit Control G on top of this, and we could go ahead and create a right side pivot over here. All right, so something like that. I'll pivot from the right side. Okay, so let's go ahead and make that our right side pivot. Now, the question is, how do we get this set up? And let me go ahead and make that group. So where, when, why, how? Do I want to add external controls? I could add an external control in front. That is just a little pivot. I could add one in back. I could add one inside. But here's one of the challenges, like I mentioned. There's never a point where I want the animator to tilt the front and tilt the back, because all of a sudden this thing's going to be climbing. So what makes more sense is to add a custom attribute. A custom attribute will allow us to basically control this in terms of how this functions. Now, how we hook up that custom attribute, that's going to be another question. But let's go ahead and add two custom attributes to our main control here. So we're going to add them right in here to the main cart control. We're going to come up here to edit, add attributes, and we're going to name these. So one is going to be the front and back pivot. And if you want, you can add underscores here. I think it might take spaces now. In the past, it didn't. But we're going to add a front and back pivot. We need to determine which one of these we want to use here. For this particular instance, we're going to use a float. What a float number means is that it contains a decimal point, so it's like 1.0001. And we can determine a minimum and a maximum down here. Now, this is going to determine how we set this up. In this particular instance, I'm going to want this single control to control the forward tilt group and the backward tilt group. So in this particular case, this is going to be where I'm going to use a set driven key more than likely in a maximum and minimum range. Now, I could base this on degrees. So for example, I could say, how far would I want this to go on the most extreme? And, we could look at this. Do I want to make it so the animator can, go all the way here to where it kind of crashes? That probably wouldn't be a bad idea. I could take a look at this and I could make it 1-to-1 with kind of the correlation of the value. So maybe I make it so it can go to 60. All right. So what I'd say is let's go ahead and do a maximum of 60 on the positive and a minimum of negative 60 and a maximum of 60. That way we have kind of a range here that the animator can use. Now I clicked off of here, so I lost my naming convention. So let me go ahead and get this set up again. Select the curve. We'll do a minimum of negative 60, maximum of 60. And we'll just make this our front and back pivot and hit add. And you'll see it adds a custom attribute. And if you middle mouse drag, so I'm holding down the middle mouse button and dragging, you'll see that goes between 0 and 60, 0 and negative 60. We can then do the same for the side. In general, it might be a good idea to make it the same. So in this particular case, negative 60. That's probably too much, but it's whatever. I could also look specifically at the amount before this, starts to become unbelievable. And it honestly doesn't take very long for us to get there before that's kind of sinking in. So we'll just do 60 and 60 on these as well. But we'll do the same thing. We'll do the, side pivots. We might do left pivot, right pivot. That's front and back pivots. We'll go ahead and make this our left and right pivots. And we'll just do the same thing. Minimum 60, maximum 60. And hit add. And that will go ahead and add in our attribute. Now what we need to do is we need to program our attribute. So let's go ahead and take a look at that process. We can come under our animation menu set, come in here to key, and find our set driven key menu. We can click the set button here to load it, and what we're going to want to do is load in our custom attribute controller as the driver. So I'll select my main thing here as the driver. You'll see I have my front and back, my left and right. From there, I'll go ahead and add in my programming. Let's go ahead and start with the left and right since they're on top. I'll select the right side, the left side, and we'll load those as the driven. From here, we need to identify the axes we're rotating on. For these, we'll be rotating on the z-axes. So I can select each of these, and then I can select their rotate z, and I can click key. What will happen is you'll notice in our outliner here, these become rhombi, so they are no longer square, which indicates they have something acting on them. This is another really nice aspect of the hypergraph hierarchy. We can confirm these do indeed have this set up. Now, what this is going to do is it's going to make it so when this control is set to the value that it was at, which hopefully was 0, you'll see is currently 0, those will also be on 0. What I can do from here is on this main control, I can take the left and right pivot. I can go ahead and increase that to 60. And I could say at 60, let's go ahead and take the left side here and let's crank this sideways. So I'll just set this to be, maybe we'll go ridiculous with this and just do a negative 100. Not that crazy. We'll just do a negative 90. So that way it can go all the way sideways. And I'll click key. Now, when I do this, I need to make sure I have both the right pivot and left pivot set up because I want the right side to key at 0 here. And what you'll see is between 0 and 60 now, it should be moving side to side. Why is it not? Let me check. Do I have the right pivot? I have rotate Z. So for whatever reason, I guess it didn't key correctly at 0. So let me go ahead and reset that here to 0 and just make sure I have this set to key correctly. I made a mistake. Notice I'm putting these on the front and back pivot. What happens when you make that kind of mistake? Well, you need to break some stuff. So if you make the mistake I did and you didn't realize, oh, I made this control the wrong thing, you can actually come into the control where it has the little blue icon. So in this particular case, I'm going to the group. You can right click and you can select break connections right here. That will get rid of that blue, and this is no longer being controlled. All right, break connections. So what mistake did I make? I had the wrong attribute here. I meant to have left and right, and I meant to have these guys selected. All right. So with left and right selected and these selected, I can now hit key, and this should be correct. What I can then do is come in here to my main control. We can go ahead and take our left and right here to 60. I can then take my left side here, rotate this to -90 like I intended. And then I can go ahead and hit key on these again with rotate Z selected. And now when I go between 0 and 60, it should pivot that guy out to the side. Like so. All right, so I can go to -60 here next, and what we can do is we can go ahead and do the exact opposite. We can take the right side here, we can rotate this 90 degrees, and we can go ahead and key that. And what we'll have now is the ability to toggle between these with this master control here, left and right, to make this wobble. All right. We can then do this on the front and back. So I'll go ahead and take the front and back ones, back and front. We'll go ahead and load those as the driver or driven. For this one, front and back are going to rotate on the x-axis. So we're going to grab our rotate x. We're going to switch to that front and back pivot control here and hit key. What that will allow me to do is go ahead and crank this to +60. I can then take my front wheels here and rotate these. Now, I intended to only go to 60 with these, but if I wanted to, I could set this to 90. I think I'll set it to 60. Yeah, we'll go to 90. Why not? Maybe the artist will want to have more than they need. We can hit key. I can then take this here, and I can rotate this back to -60, and then we can go ahead and do the back pivot. We can rotate that to -90, and then we can go ahead and hit key on these. All right? So now what we're going to get is we're going to get this set up here where we have the front and back pivot able to go. And what's most important here is that they are separate from each other so that we could combine them. And you can see it can go up on that. The one downside, though, is because those are pivoting from the front wheel, if I do it from the back here, you'll see, oh, actually, it works. Huh. I was not expecting that. That actually worked better than I thought. Cool. But we do have a slight issue here, and that's that this control doesn't control those groups. So what does that mean? It means if I move this guy over here and we try using that front pivot, it just broke. We try to use that side pivot, it broke. All right, so we do have to kind of think a little bit further. If we're going to set this up, well, that's going to change the role of this control. Because whereas this control can still rotate these, it can't move them. So now we need to create another master control for this. And that's where this final little curve is going to come out here. I can go ahead and snap this guy into place over the top of this. I can go ahead and make it a bit bigger. And if I want to, I can isolate this. And then just go ahead and place this here. Shape it a little bit. Freeze its transforms. And what this is going to do is this guy is actually not going to control any joints. It is going to control the entire rig. And we can go ahead and give this a specific name. So this one here is kind of the cart control rig. This one here could be the Minecart rig all, meaning that everything is inside of it. And we'll just take that right side pivot and we'll parent it underneath. And what that will do now is it will make it so that this rig all here, as it transfers our rig, transfers that group. And now this here, our little pivots, actually are going to still work wherever this goes. All right, so very important step. Now, at this point, we have a complete rig, not just with our MVP, our nice to have. This is where we really want to take some time and save. So I'm going to do a save scene as, and we'll go ahead and make this our Minecart rig 03. And we're almost done. So what do we have left to do? The last thing that we need to do once we have our MVP and we have our nice to have in place is to clean it up. And you're probably thinking, hey, didn't we do a pretty good job of that? We've been naming everything. Things are in nice hierarchies. You're correct. But if I come to this control here, how does the animator know they're not supposed to move this? How does the animator know they're not supposed to move this, right? So what cleanup is basically making your rig fail-proof and easy to use. You're saying, hey, you can do this, but you can't do that. So let's go ahead and start with one of the most obvious ones here, this main control. What does this even do anymore? This main control used to be for translating. It could still potentially be for rotating, but I don't know if we really want to do that unless there's like a reason we might want to have it go on its front wheel and then still rotate from its center point. It makes a little bit more sense to maybe rotate with this, but you can see that rotation does let us keep the revolving here. So maybe we want to keep the rotates, but we absolutely don't need the translates, we don't need the scale, we don't need the visibility. So this is where lock and hide comes into play. What we can do is we can take the attributes we don't want the animator to animate, and we can lock them, which means they can't be changed, and then we can hide them. The way we do this is we highlight them. So for example, we can click and drag from Translate X down to Translate Z, and I'm just left clicking for that. We can right click, and then you'll see the options down here to lock, unlock, hide, or lock and hide. What we want to do here is lock and hide these. Now, what I encourage you to do is open up another project, though, and practice this with locking and hiding, and understand that there's ways to kind of get these things back if you need to. So let's go ahead and lock and hide these. We can go ahead and get rid of the translates. We can then highlight down to scale and visibility, and we can lock and hide these. So now when an animator comes in here, they'll see, okay, I can rotate this thing, or I can use these pivots, and that's going to be all this control is for. We can do this exact same thing on these other objects. So for example, these wheels, all they need to do is rotate an X. So I could literally highlight everything but rotate X here and do a lock and hide. And now when an animator comes in here, they can see, okay, well, the only thing I can do is rotate X, so that's what this is for. It's for turning the wheel. I could go ahead and do the same thing back here. It should still also be the rotate X, so we'll just highlight everything but the rotate X, lock and hide. When it comes to the bucket really should only move side to side on rotate Z. So I could go ahead and highlight everything here, and I could lock and hide that. And now what we have is a nice cleaned up rig. In this particular case, we don't actually have a way to make it scale. I'm not going to worry about that today. I'm going to lock and hide these. If we wanted to make this so it can scale, we could add a custom attribute. But we're going to go ahead and move this. We're going to rotate it, and we'll talk about custom scaling later, maybe on a different rig. Or maybe we'll touch base on it, before we finish this up. But there you go. That is going to build our basic rig. Now it's kind of cleaned up. The next thing that can be nice is kind of alter some coloration on the controls. This isn't really necessary, but sometimes they're a bit hard to see, and it's kind of hard to distinguish this control from that control from this control from the wireframe. So if you guys want to change the colors of a curve, you can select the curve. You can come into the attribute editor here, and what you want to look for is going to be the drawing overrides in the actual control. So we'll come in here to the bucket control. Let's see. I think it's the first one here under display. Drawing overrides, and then you can enable override here. And you have two options. You can either pick an RGB, which is usually what I like to do, and let's just say we want to make the bucket red. We can make the bucket red. You can see we have that set up there. So we can come to the first one, find that front control rig, enable drawing overrides, and I could come to RGB, maybe switch this to be blue, come to this one over here, enable overrides. We could go ahead and switch this one to be RGB, and we can make this one, maybe yellow. And then here, I'll do a similar setup here where I go RGB. We'll go ahead and make this one bright red. And then I'll come into this last one out here. We'll go into RGB, and maybe we'll go ahead and make this one blue. So that way we can kind of see that. We can see that separation. So now you can see we have this really nice strong color coding. These are exactly what the animator needs to see. We have a pretty cleaned up rig. What we want to do as kind of the final thing is we generally want to consolidate our hierarchy here into one hierarchy. You generally don't want to have multiple. Now, this is pretty straightforward. We're just going to put the joints into a group. And we'll just go ahead and name this our joint underscore group. We can do the same with the controls. We can put the controls in a group and make this our CTRL underscore group. And then we can put everything in a master group here and just make this our Minecart underscore rig. And now this is going to show up in the outliner as a single asset. So when this is part of a larger scene, our artists don't need to worry. We can also use our layers over here to kind of help us out with this. So I'm going to delete the existing layer I have here. I'm going to leave the rail layer because we don't need it. To delete a layer, you can just right click and delete. The rails here, we'll leave it because it's in the master file. But I could go ahead and create one for geometry here. So I could take my Minecart Geo, add this to a layer. We could just make this our Minecart Geo underscore L for layer. And what I want to do is set this to be a reference. That way we can't select the geometry. As you might have guessed, we'll also do the same thing with the joints. We'll create a layer here, which is going to be the Minecart joint underscore L for layer. And we'll go ahead and set that to a reference, so we can't select those. And then we can also give one to the controls here. We can go ahead and create a layer here and just make this our Minecart CTRL L. And this one we want to leave selectable, but we can toggle it on and off if we need to. And we can do the same thing with the joints. Now, the last thing I want to show you guys is creating a global scale. And then I think after that, we're pretty much ready to test. But just to show you guys, if you did want to make it so this thing could scale up and down, we generally do that with a custom attribute by coming into our main control here, going to edit, add attributes. We'll do a float once again. We'll name this one global scale. We'll set a default value of 1 because that's what scale is at, and no minimum and no maximum. That will allow these to go infinite and just hit add. From here, what we need to do is figure out what we need to add. A lot of the times we need the joints. In this case, we might actually need the controls, and we might actually need the geo. So we need to think about what needs to work together here. If I take all 3 of these and scale them, you'll notice it scales uniformly. Now, generally, you don't actually want to scale the geo if you're using skinning. We're not using skinning, so we'll want to do the geo. You might be wondering, do these groups have a purpose? And hopefully this answers your question. You can come up here to Windows, General Editor, Connection Editor here. And what we can do is we can go ahead and load this as our main output here. So we'll reload left, select our global scale. And we can go ahead and hook that up into our control group here. We can click reload right. We can go ahead and find scale in here. And we can go ahead and make this control the XYZ of the control group scale. So now when I come in here and I use my global scale, you'll see those joints scale up. You might be wondering, I'm going to do that to all these. And yes, we can go ahead and take our joint group, reload right, go ahead and hook this up to the scale of the joint group. And now if I go ahead and use that global scale, it'll scale the joints. And likewise, I can come in here to the geo, reload right, we can come to scale here, and now this global scale will also control these, and we have a rig that can scale up and down for this object. All right, so that's going to be our final control for global scale. Most rigs have a global scale, that's the reason I set it up. But at this stage, we have a nice clean rig, we're ready to save, and then we're ready to save our final rig. So what I usually like to do is do a save scene as, hit our up arrow here outside of the work in progress folder, and we'll go ahead and make this our Minecart rig V01 for our first version in case we need to make changes. All right, so that's going to be the process of completing our rig. At this stage, we've gone from breaking down the concept, analyzing our documents, creating our MVP, our nice to have, placing our joints, adding functionality to the joints, troubleshooting some of the issues we ran into with pivots and the object not being able to move, and bringing it all together by cleaning up the rig and adding in our final attributes. What is left to do? The final thing we have left to do is a test animation. So what you want to do after you build a rig is you want to do a stress test. A stress test basically is going to allow you to test all aspects of the rig and whether or not they are working. However, we do not do that in the rigging file. So the first stress test is to save, to create a new scene and ask, can this be referenced? Which sounds a little bit complicated, Yeah, why wouldn't it be able to be? But sometimes when you have a reference within a reference within a reference, it causes problems. Now, if you followed along correctly, you can come down here to the reference editor, hit your plus icon, and we can come into our rig. We can bring this in, and we shouldn't have any issues. I say shouldn't, but who knows? From here, we can go ahead and animate this. Now, I might want to give myself a little bit more track than I currently have by coming down here, finding the geometry here, and maybe duplicating the tracks if I can get away with that. So there's that as a factor. Maybe I'll go ahead and give this kind of a length of 3. But from here, I want to test how easy it is to animate. So let's go ahead and give this 180 frames. And we'll just go ahead and maybe start by grabbing all of our controls, hitting the S key here, and then moving to the tail end and hitting the S key here at the end. So now we can see, hey, does this move? And it does. Now, in order to make this kind of continuously move, I need to check the wheels. I'm not going to do the math to figure out how many times these need to revolve, but if I go ahead and take the wheels here and I just rotate them in the direction we should be going, and just give this like a huge number, like 5,000, and go ahead and hit the S key at the end, those wheels should be good. Now, that looks kind of awful, so I don't think 5,000 is correct, but at least I can say, hey, those wheels are rotating, so that's good enough. Now, the next thing I want to do is kind of experiment with the card itself. I'd like to maybe experiment with these pivots. So, for example, maybe I have it pop a wheelie here when it takes off to make it look like it's taking off entirely too fast. So maybe it's going to kind of kick up there, and then maybe it's going to come down. And maybe we make it, kind of overshoot a little bit and then settle down here. So what we end up with is kind of a nice little rickety rock here as it goes. Then along the way, maybe we come in here and we say, all right, around this area, we're going to call that good, but we're going to go ahead and make it kind of rock to one side here. And then as it goes, maybe we're going to have it switch to the other side. And then we'll maybe have it switch to the other side, and then the other side. And then finally, as it gets to here, we're going to kind of settle in. We're going to no longer be doing that, but to make it have comedic timing, we're going to make it skid to kind of a halt here. Maybe too much of a halt, and then it's going to slam back and then settle back down finally. All right, so do all these things kind of check out? And they do. So it's working as intended. I think this is good to go. We don't have any issues. It looks nice. Now, there is one kind of caveat. How does this thing do on turns? But we're not going to concern ourselves with that here, since this is all we were kind of given. We're going to assume that maybe it's just going on a straight track down a mine shaft, and we don't need to worry about turning. If we did need to worry about turning, we'd probably have to worry about a front pivot, a back pivot on the main control to make it rotate from. But as far as we're concerned, this is golden. So this is exactly what we want to see at the end of this, to have a complete rig. And if those other controls need to be added later, they can be. So let's go ahead and kind of go over a couple last things here, just in terms of this, and talking about the structure. With referencing, this is a live document. So one of the things I do want to show you guys is if I go ahead and open up our main file here for the model, and let's say, the modeler kept working on this, or the texture artists were introduced. All these various things could have things like materials assigned. So I'll just go ahead and add in a standard surface here. We'll go ahead and maybe make it a bit darker here, and introduce metalness, and then add a bunch of roughness. So it's kind of a rough metal cart. Maybe make the color a little bit brighter, but this could be our rough metal material. I could do the same thing on the wheels here. I'll go ahead and select these in face mode and just kind of assign this. So we'll assign our existing rough metal. Do the same down here. Assign existing rough metal. And then, through here, we'll just assign a new favorite, and we'll make this one something like wood, I guess. Old wood. But we'll go ahead and just kind of give it a brown, and go ahead and apply that to these other areas here. Brown's pretty dark, but we can adjust that. So we'll give that our wood material and do the same thing here. But you can see that we can continue to work on this. That's the main thing I want you guys to understand here, that this file, is not necessarily done. It's still in operation. And if we've set up our rig correctly with all our references and stuff, this can continue to be modeled, it can continue to be textured. And now if we go ahead and open up that final rig, it should all be in here and connected. So we should see those colors update. All right. So hopefully this gives you guys a better idea of the comprehensive process of building a rig start to finish, actually going through troubleshooting it, trying to understand it, and having a good comprehension of how we can approach it.